Hello, and welcome to our session 2020 and Beyond, integrating Sitecore with emerging technologies to wow your customers. We are Julia Gavrilova and Brian Henderson, the Sitecore architects from Exentium. Today, we're going to talk about latest trends in user experience, such as augmented reality, 3D presentation of products on a page, and visual search. You probably have seen mobile applications that provide ratings for restaurants, directions to places, and such. Various industries are getting more and more engaged, adapting AR technology and other visual features. Retail is probably the most active one in this area, with their senior space and virtual fitting rooms, but others are not far behind. Let's look at how to implement a couple of these features. We'll start with the 3D product page and senior space feature. Here you can see a bike product detail page with a 3D model of the bike. I can interact with it, turn it around, click on the buttons on the bottom. That will change the frame color of the bike. I can change it and see in different colors. Same page on the mobile device. I can, again, interact with the model, but now I have additional button view in your space. When I click on it, I can render this bike in my room, walk around it, look at it in detail, and figure out exactly what it is that I'm about to buy. Let's see how we can build this feature. First, you would need a 3D model, and you can use any of the 3D software like 3D Max, Maya, or Blender. I'm going to use Blender to save myself a little bit of time. I also downloaded already built model from CD Trader site built by Semyon Filipov. Once I have the 3D model, I can convert it into appropriate formats. For Android, it would be GLB and GLTF. For iOS devices, it would be USDZ, which is a Pixar format. For Android and Windows, I used Windows 3D Builder and Windows 3D Viewer. For iOS, I had to do a different process. Here, I'm going to open my bike file in Blender. Click File and export the file into USDC format. And I'm going to click on the desktop. And click OK here, and go to mountain bike folder and save it right there. Click export. The next step would be opening up Reality Converter, which is a Mac tool. And when it's open, I can now import the file that I just exported from Blender. It's under the desktop. A mountain bike USDC. And once it's loaded, I can click import. Here we go. It's running through the conversion. And once it's done, and I validate the bike and make sure that everything checks out, I can now export the file into USDZ format for iOS devices. And I can click save. Once I have the files ready, I can upload them to Sitecore. You can store these files either in Sitecore Media Library or in the Content Hub. If you choose Sitecore Media Library, you would have to add the MIME types for these files to IIS and Sitecore config file. If you choose to use the Content Hub, you would have to add a couple of tasks for these file formats to the media processing pipeline. To render these files on the page, the most easy and cross-platform way would be using Google's Model Viewer component. To switch the color of the frame, I used just swapping the poster and the model. The posters are the preview of the 3D model that gets loaded before your 3D model file is fully loaded, and the component takes care of the switching for you, so you don't have to worry about that. That concludes our first section, where we just looked at more of a low-hanging fruit in AR and 3D user experience implementations, but there's more. And I would like to show you another example where we changed the way users look at the printed marketing material. I have two postcards that I would like to add AI experience to. The first one should render a video augmentation, and the second one would render a 3D bike on top of it. Here I have my mobile application where I'm going to select bike postcards, menu item, and in the camera view, I have two of my cards, and immediately they've been recognized and augmentation have been added. If I take the card and turn it around, I can see that the bike is tightly glued to my card, and I can see the details of it. To create this AR experience, I used Wikitude, Wikitude SDK, Studio, and Encoder. For WTC marker file, I used the Studio. For W3, the model of the bike, I used the encoder, and I didn't have to do anything for the videos because MP4 format is supported. Here you see my Wikitude Studio with Symposium 2020 project. It's of an image type. I have two cards here, card 2 and card 1. Both of these cards have 3 stars at the top right corner, which means that they're good for the image recognition right there. And I can download WTC file right here. I have 2 targets there, but I'm not going to download it because I already have it uploaded to the Content Hub. Then I can switch to the desktop in Sitecore, and I have the item structure here. Bike item represents the marker, and it has a reference to the Content Hub. 2 child items represent the models. The first one has a model name of card 1, which matches the target in my Wikitude Studio project right there. And the second item represents the bike. Again, I have the model name and the reference to the Content Hub. Now, if I switch to Xcode, in my JavaScript file, I have 2 endpoints at the top of my file. Both of them point to Sitecore item services, right there. The first endpoint will bring back models. The second one will bring back, actually the other way, models and markers. And the most interesting part of the code is right there, where I'm retrieving the data from Sitecore, parsing it, and creating image trackable. And then an image recognized. I'm looking up the item that was recognized based on the target name and finding the model right there. Once the model is found, I can check whether the model is of WT3 format right there. And then I create a model. And if it's MP4, that I'm creating video drawable, which all of these objects are Wikitude SDK objects, and just adding another final method to wrap everything up. That's really it. You don't really have to do anything other than that. And that concludes my section, but Brian has something else interesting to show you, and it's a visual search. Take it away, Brian.
Yeah, thank you, Julia. I think those are really unique and exciting ways to enrich the user experience. I think your updates to the product detail page are very engaging, but I want to do something different, and I want to make it easier for our users to find those pages. When Julia and I were first envisioning this presentation, visual search was one of the topics that we were most excited about. I stumbled across this quote from Gardner, and I think it highlights the impact that this feature can have. Increase your revenue by 30%. Let's do that. That sounds good to me. So what is visual search? You've probably seen it already. A lot of the larger platforms and branded apps such as Amazon, Google, Bing, and Pinterest A lot of the big box retailers have already jumped onto this trend. Visual search uses real-world images, your screenshots, internet images, photos from your phone. They use that as the input to drive your online search. From there, we can leverage the power of artificial intelligence to understand the content and the context of the image that's been uploaded. This is changing the landscape of search as we know it, and the future of search really is going to be pictures rather than keywords. People don't want to type anymore, and everybody has a phone in their hand. Our goal is to get them to our products with as few clicks as possible and less thinking. Another benefit of this technology is that it can break down language barriers because they're just uploading an image, and also has the potential for folks with disabilities to have an easier way to find what they need online. On your way to work, you can just take your phone out, take a snapshot of something that you see, and instantly get results of products similar to what you're looking for. Today, I'm going to demonstrate leveraging Sitecore Content Hub as a source to create our custom vision model utilizing Microsoft Azure Custom Vision AI. We'll import our images. We will have them tagged for us automatically, and then just using the data that we already have, we will train and evaluate our model. Finally, we'll use that new custom model that we created, and we'll use that to power a visual search interface that we'll add to our website. Today, there are already a plethora of visual search APIs available, and you might not need a custom model. To speed development, there are out-of-the-box models for retail, manufacturing, food. But for our demo, I wanted to build and leverage a resource that we already had. We wanted to train our model to have understanding of distinctions that are unique to our product line. Our Exentium team maintains a fictitious e-commerce site called King and Bear. You saw some previews of that in Julia's piece of the presentation. We use that for demos and presentations, but it leverages Content Hub's digital asset management and product content management for the e-commerce functions. The heart of this DAM platform is a storage location where users can access and manage all of their disparate content. It's a single source of truth for us. All of our marketing assets are there and ready for distribution. It's more than just basic storage because in addition to all of those assets, we store all of the complex metadata that describe our products and describe our assets and images. So that being said, we thought that that would be a great source to drive our visual search. And now our visual search can know specifically just about our content as opposed to just in the industry standard. Here we're going to take a look at our Content Hub and see what we have that's driving our custom vision model. In Content Hub, we have all of our assets. Each of these assets, we have all of our attribute information about the asset, different descriptors and metadata. Each of these images ties into a product. The product has what you would expect from a commerce store metadata. All of our product families, our metadata, our attributes, our sizes and coloring that describe the product. We'll go into Azure Vision AI and get a project started. So we'll go log in, and the next thing we'll do is get our custom console application. This is a C# application that we built. It's really less than 200 lines of code that connects to our Content Hub. It's going to pull all of those images and metadata. It's going to iterate our product collection. You can see here, it's going to iterate all of the available assets that are associated with those products. The next is going to upload those to our AI model and add the tagging for each of the product families. Once our images get processed, at the very end, we will trigger a model training run. So we need at least one training run in order to create a model and publish an endpoint. For our purposes, we're just using the quick training. There are advanced training options, but for this, we're just going to do a quick training. We'll publish our iteration, and this will push that out to our prediction endpoint. The last thing that we'll do is we'll upload a test image, and that test image will test that prediction endpoint. Our results are really good. As you can see, we got a good result that identified our test image of a bike. Here we're looking in Azure Custom AI, and these are all of the products that we uploaded. We uploaded a bike, and it got tagged as a mountain bike. Next, we'll go in and look at our iteration. So this is the iteration that ran behind the scenes for us. These are all the tags that got uploaded. Each of these tags is a product family in our catalog. And this is the test image that we uploaded as our training image. It got incorrectly identified as an indoor bicycle. We want to classify that as a mountain bike, and this will improve our model. This is a key to building and refining your model is testing it and correcting the incorrect classifications. So what we've done essentially behind the scenes is we've created and trained a vision model. We have recognized the major differences between images. The AI is learning about our model, prototyping that model with a very small amount of data. Depending on the complexity of the problem that you're trying to solve, it may require hundreds or thousands of images, but for this demonstration, we've only uploaded, I'd say probably in the average of 20 images per product, and we got a very good results from that. But how do we improve that? The more images that you add, you need balance between your images, things with varying background, lighting, flashes versus no flashes in the imagery, different exposure levels, object sizes, camera angles, all of those things play into how the AI does its learning. Just as important are using negative images, images that don't have anything to do with our model, that we can tag those as falses. It's also important to focus on the relative quantity of images. You want your model to be balanced. So you need, for each of your tags, you want them to be as close as possible. And you need to maintain at least a 1-to-2 ratio between your tag with the fewest images and your tag with the most images. So say you uploaded 500 images for one tag, you should have at least 250 images for your lesser tags. That will give you an even balanced model, and it allows the AI to do better prediction. Sometimes the AI can learn things based on arbitrary characteristics that you weren't anticipating. Let's say, for example, we want to classify objects of fruit, and we're showing our AI pictures of apples and oranges. Along the way, we realized we've been putting all those apples and oranges on a white plate for all of our pictures. The classifier may pick up on that white plate and think that is important to our model and our image when it's really not. So that's where this comes important to have all those different variances of where your image is. Maybe you need to add some being held in hand or sitting on your desktop. The next piece is we're going to evaluate our model. The precision, how likely is it our images are going to be correct? Out of the tags that we've uploaded, what percentage did our model correctly find? And then we have, Microsoft provides an interface to give us an overall measure of our model precision. What we used in this demonstration was just the quick learning, but you can do advanced learning. And with the advanced learning, you must specify a compute time and budget. So the custom vision will sit there and experimentally try to identify better ways to train your model. The more that you train, the better your model is going to be. It's up to you to set what your budget for that is based on your needs. The model test is a continually improving process. So everything that we add to our model, the more that we run iterations, the more that we run test data through it and go back in and reclassify those tags, our model will continue to train in the background. Next, I'm going to demonstrate a quick interface that we can leverage to utilize that model that we just built. We need in various formats. It's available for mobile devices if you need for real-time video or image analysis where you're not wanting to call an API for much higher processing speeds. For our purposes today, we'll just make use of the REST API. This endpoint, we can submit a binary data of our image, and it's going to return a JSON response. It's going to show us our image classification, and it's going to give us the details about that object that's been identified. Next, we'll use that result to drive our product query and give us a result or give us a display of similar items that a user might want to purchase. Here's our King and Bear site. I've augmented this with a new search icon with the image. Take a quick picture, look around the room and find my child's bike. We'll snap a picture of that. That's been uploaded now to our Azure endpoint. If you can see here, it's been identified as indoor cycling. This is the JSON response that we get back. Normally our interface wouldn't have these things, but this is for demonstration purposes. But off of that result, we've tied that to our products, and there we go. There's Julia's bike. It's almost the reverse. So we took a real world product and uploaded that picture, and we got her product recommended to us. Next is just our resources and references. This is a great list to get you started. Both the Content Hub and the Azure AI are extremely well documented. Very easy to get in and get started. A lot of great examples. One thing that I did leave off, and I'm sure I'm going to get questions about, is what we used for the image capture. HTML5 now has a Get User Media, which gives you access to the local device's camera and phone. It's just baked into most browsers now. It's very widely supported. It's a great way to get the video without the need of a plugin. This is also available on mobile device. So this demo that we have today, we could have just snapped that picture from our phone. So that concludes my demo. Thank you for joining us today. We really appreciate it. We hope you're as excited and passionate about integrating new and emerging technologies into your Sitecore solutions. Please reach out to Julie and I directly if you guys have any questions, or feel free to reach out to anyone at Exentium if you'd like to schedule a custom or private demo. I believe now we're just moving on to our Q&A session. Thank you again.
Thank you everyone for watching this session. And we are live now. So we have Julia and Brian here. Thank you for your session. I think it was really informative, and we are looking forward to have your questions. Please put them in the question box and we are answering them live. So we have our first question. Would you have an example application for B2B services?
Would it be pertaining to augmented reality or virtual search? But Brian, do you want to speak to that? Or
yeah, I'm trying to think of what scenarios for visual. I'm trying to think of what scenarios for visual search that we would have for B2B.
Yeah, same thing. I think visual search and things like augmented realities a lot of times providing user additional information about an object or a service. We don't have examples per se, but you can probably implement something for visual search and for augmented reality for services maybe that you provide that might be not necessarily B2C, but maybe B2B. But in general, I think we're just scratching the surface of all these features and trying to see how it would benefit our customers at Exentium. And Exentium has done a lot of B2B and B2C work. So yeah, if you have something in mind, come join us and we can talk about it.
Yeah, the only thing that comes to mind for me is, in the B2B is we could use any source. In my demo we used a Content Hub, but there may be some other APIs or some other catalogs that you want to provide a visual search interface to. So that would definitely be a possibility to have those drive your model training and have those drive your search interface. Maybe your B2B customers need an easier way to find, you have a catalog of 30,000 SKUs and they need to be able to drill down to something specific. I think visual search would be a good way to drive them into, those products faster.
Okay, thank you.
Sure.
And you mentioned a couple of the tools you used. I imagine that you can use any other tool which can provide the same results as an output, for example, for the augmented reality part. Is that correct, Julia?
Yeah, you're right, Thomas. Well, I used, for the sake of this presentation, I used Cordova. for mobile applications, but you can use Unity. And there are a lot of different SDKs for augmented reality that are available for Cordova, for Flutter, for Unity. So for, I guess, Wikitude SDK is something that I came across about a year ago, and it seems to have very reliable results in terms of recognizing images, and they also do object recognition. So I felt that there was probably a way to go. But there are definitely other SDKs out there that you can try using. And in the supplemental material that will be on the page eventually, you'll see that there are links to various resources and links to everything that I've tried using and I've used for this presentation as well.
Yeah, for the vision search, there's quite a few platforms available to build your models. I leverage Azure, but Google, AWS all have cognitive service platforms, and then also for my demo, for my search interface, I relied on JavaScript on the front end to query a REST API. But once you've built and trained your model in Azure, you can export that to various platforms. TensorFlow for Android, you can export it for iOS. For Microsoft, you can export those for scenarios where you want to do more real-time image analysis. I think probably one of the distinctions between what I did was image classification versus image detection. So the image classification is just finding the relevancy of the tags that you've tagged on objects and returning to you what those tags are, versus an image detection will also identify the objects within an image and tell you where they're located within an image. So on the Azure side, for setting that up, there's two different services that you require. So the one thing that we use, or the two things that we used for that application were the training services and then also the prediction service. So while we went through the upload process, we were uploading all to the training service and building our model. Once that model was built, we exported it in a format that goes directly to the Azure prediction service. And so then our prediction service is what we're querying to get the results from our search page.
Thank you. And here is a very relevant question regarding privacy. Do you have any information, because your customer's mobile device using your application should require access to the camera?
Right.
Is this a concern? Did you see any negative reaction or?
Not necessarily, one, because the user has to approve the use of camera. You can't just hijack the camera. So the user is aware of the fact that the camera is going to be used. And if they don't want to use it, then they're not going to allow the usage of the camera. And in Brian's example, it's done on a web page. So the same thing. You're not going to be, your camera is not going to be hijacked. You're always going to get the warning that you need to allow the page or the mobile application to use your camera. So from that perspective, I don't see it being an issue.
Yeah, I think in my demonstration we skipped that prompt. So the first time you try to use the visual search, you will get a prompt from the browser that the user has to accept. So you can accept that long term, or you can just accept it temporarily. So I think in my demonstration we had already accepted that, so it just went straight into the use of the camera. Okay, and next question is there any difference between Sitecore versions? Did you use a specific version of Sitecore, or did you leverage anything like SXA inside Sitecore when you built this demo?
Not SXA, right? King and Bear actually is a demo site for Exentium Flex product, and we used Flex for that website. So everything, all the components were done in Flex. It was, I believe it's running right now 9.3, but I tried the same exact demo, but with Unity on 9.2, I believe, last year. And it doesn't really matter as long as you have item services that are used or GraphQL or any of the Sitecore services, you can leverage the data that you can pull out of Sitecore services and just process it in a mobile application.
And then for my side on the visual search, we leveraged Content Hub. So one of the key components of Content Hub is the product content management. And so that we have custom schemas for all of our products that contain all of our product metadata and product hierarchy. And so that's what drives our commerce store. And then from the search aspect, the front end was JavaScript, but once we get the tag back from the classification prediction endpoint, we just submit that into our existing Sitecore search API that was already returning our product information. So that just became a new input model or a new input into our existing search.
Great, thank you very much again. This concludes our live Q&A for today. Thank you, Julia, and thank you, Brian, for your presentation again.
Yeah, appreciate it. Thank you so much.
Thank you.